Now we will discuss some more questions in the area of carbonyl chemistry. Among the organic compounds containing oxygen, the carbonyl compounds form a major part. There are a number of other compounds like alcohol, ethers, carboxylic acids, and a number of derivatives of carboxylic acids contain oxygen. But the carbonyl, whenever we discuss about the organic compounds containing oxygen, the compounds of the type carbonyl compounds, namely aldehydes and ketones, are more important compared to the other compounds. So we will discuss a little more of carbonyl chemistry, which forms the bulk of the oxygen containing organic compounds. Let us look at the question, fifth question in the series. When we just simply look at the question, we will find that these are all two compounds or two starting materials which undergo only Cannizzaro reaction. Normally in a Cannizzaro reaction, what happens? Two molecules of the same aldehyde, that is two molecules of formaldehyde will react, it will undergo a disproportionation. What is meant by disproportionation? When two molecules are involved, one will undergo oxidation, the other will undergo reduction. That is what is meant by disproportionation. Similarly, two molecules of benzaldehyde can also be there, can get oxidized and reduced. But in this case, we have one of each. We have one of benzaldehyde and one of formaldehyde in the presence of the base. Therefore, such a type of Cannizzaro reaction, because these are the two species will undergo only Cannizzaro reaction, this will not undergo aldol condensation. Therefore, what will happen when we have a mixture of these two things in the presence of basic medium? So, normally what happens is two aldehydes or ketones will undergo disproportionation reaction, two molecules are involved. Now, when one molecule is involved, which will undergo, the question now is, this is what is referred as a cross Cannizzaro reaction or mixed Cannizzaro reaction, because the Cannizzaro reaction is affected by means of two substances. Therefore, this is referred as a mixed Cannizzaro reaction. So, that is the first point to be emphasized. Now, another big question arises. In this Cannizzaro reaction, normally a hydride shift occurs. That is actually when you take formaldehyde, two molecules of formaldehyde, one molecule will be treated with the base. It is something like one molecule of formaldehyde, just to look at the mechanism, this base will get attached to this, and then the carbonyl, the compound, and this immediately will move over to this position. And then one hydride, as a result, what will be the resulting structure? The resulting structure will be like this, O minus. Now, one hydride shift occurs. Another molecule of this formaldehyde will be waiting, and it is not a hydrogen shift, it is a hydride. That is, hydrogen is a pair of electron, it will shift to another molecule of formaldehyde like this. And then further reaction proceeds, leading to disproportionation. So, hydride shift is a very important step, or it is a crucial step in a Cannizzaro reaction. The question is whether the hydride shift will occur from this as I have given here, or the hydride shift can equally occur from benzaldehyde molecule, which will be the one that is happening. So, in order to explain that, generally it is believed that a more powerful reducing agent, both are reducing agents. Benzaldehyde also can be reduced and can be oxidized, or it is a reducing agent, and similarly formaldehyde is also one of the powerful reducing agents. Between the two, which is a stronger reducing agent? It is the formaldehyde that is reducing agent. Therefore, whenever formaldehyde is involved in a Cannizzaro reaction, it is always the formaldehyde that undergoes the oxidation to give rise to. Normally in the Cannizzaro reaction, the acid is not obtained, the acid anion is obtained, formate ion is obtained, and it is not the acid that is being obtained, and benzyl alcohol gets reduced. So, this will be a product that is formed. So, this is a mixed Cannizzaro reaction. The idea being conveyed by means of this reaction is, it is not the benzaldehyde that is getting oxidized to benzoic acid. It is only the formaldehyde that is getting oxidized to formic acid, from which of course a proton is removed. Always whenever an acid is formed, acid is never found as a final product. It is only the anion of the acid or the formate ion is being formed, and of course the alcohol is being formed as the other product. So, this is how we will have to look at this reaction as a mixed Cannizzaro reaction. Coming to the next question, this is a very simple question, but at the same time it is a very interesting question. Normally all aldehydes other than formaldehyde, formaldehyde actually exhibits the behavior, it is a very powerful reducing agent, and all aldehydes on reaction with ammonia will form a sort of a what we call as an adduct, that is called as an aldehyde ammonia. Supposing acetaldehyde is there, when it combines with ammonia, it forms acetaldehyde ammonia. some other aldehyde will form that particular aldehyde ammonia. It's a sort of an addition product. Ammonia and the aldehyde will form an addition product. But in the case of formaldehyde, the reaction is something different. When formaldehyde reacts with ammonia, it forms a ring structure. The structure of the ring is like this. This is the structure of the ring. This is known as 6 methylene groups are there. Each one is a methylene ring bent. The ring junction, it's not a ring junction, it is a sort of a bent line. 1, 1, 2, 3, 4, 5, 6. Therefore, it is hexamethylene. C6, CH2 6 times. And how many nitrogens are there? 1, 2, 3, 4. It is 4. Therefore, it is referred as hexamethylene tetramine. It is not hexamethyl. It is not a methyl group. It is a methylene group. So you have to be careful. Hexamethylene tetramine. Or this is also known, is used in medicine as a urinary antiseptic. So it is known as urotropin. It is also known as urotropin. Hexamethylene tetramine or urotropin. This is the compound that is formed, and this is the specific compound that is formed when formaldehyde reacts with ammonia, which is totally different from the reaction of other aldehydes with ammonia, which will form only an adduct or an aldehyde ammonia. So this is the structure of, it is very easy to remember, write alternately nitrogen and methylene in the form of a 6-membered ring, have a central nitrogen, connect each nitrogen by means of methylene groups. We will get the answer for this question. This is the structure of hexamethylene tetramine.